Hey everyone, this is the Ghost with GhostlyHaks.com. Today we're going to be flashing MacBook Air and a MacBook Pro board. We're going to be flashing the EFI in order to remove the EFI password, or the firmware lock, as most of you call it. I'm going to run through the basic materials that you're going to need to do this, and I'm going to show you the pinout and such, and introduce the Rev 2 of my MacBook Air Easy Flash clip. Later on in the video, I'm going to SSH into the Raspberry Pi here, and we're going to flash both the boards, and I'll show you how that works. And then we'll go through on how to remove, if we can, the affected area where the password jump lives. Anyways, so enough rambling on about that. Let's go through some of the stuff. You're going to need the Raspberry Pi. Doesn't matter what model, A, B, B+, Pi 2. We'll be using the GPIO headers here. You're going to need some sort of clip to interface. This is an SOIC Pomona clip. It's an SOIC 8, and it clips right down on top of a board like this. I'll show you that in a sec too. And I know this kind of looks scary. These are wires as well. These are just some female-to-female connectors that I've got labeled out. And this is breadboarded for the 3.3 volts that go to 3 different pins on the chip. And this is the MacBook Air Easy Flash that I developed, and I'm going to be releasing this one, actually the revision 3. This is revision 1. I'll show you revision 2 in a second. I'll be releasing revision 3 for sale very soon for about $30. Just for comparison, here's revision 2, and revision 3 is going to be a little bit smaller than revision 2. Revision 1 on my right hand side, it's a little bit bigger, eh? Revision 2's got a couple improvements, and revision 3 will finally probably close everything out. I'll probably just do the first version, be revision 3. And I might come out with a version 2 later. I know I'm saying revision and version. Version 1 is going to be the final revision of the ones that I'm making. And version 2 will probably have a couple more switches on it, depending on how Apple goes with newer boards. Anyways, so you're going to need a clip like this for a MacBook Air. You're going to need a clip like this for a MacBook Pro. And finally, you're going to need a version of whatever OS you're going to use for the Pi. I use Raspbian. I actually have an image that I'll put a link in the description below for the Raspberry Pi that you can download. It's just under 8 gigs. It's around 7 gigs, I think, something like that. 7.5, I don't know. It'll take a minute to download, but it has everything already pre-installed, updated on it as of today's date, which is, I really don't know. I'm kind of tired. Anyways, you can download that, or you can just follow along with the setup. I'll kind of run through that in the SSH portion of the video. I'm trying to keep this video short, but it's going to be a pretty long one. This is the board. This is for a MacBook Pro. This is the EFI chip on it. I know you really can't see it, but this would marry up to it just by clipping right directly on top of it. Just like that. And then you would do the flashing procedure. You would just have to make sure that orientation is correct, and you would have to make sure that the pinout to the board is correct, or to the Pi is correct. Now this is a MacBook Air. It's a bit simpler, especially if you have my clip. And basically, this header right here is what we're going to interface with, and you would just take the clip and clip it directly down on top of it, and then the pins on the back side that are connected to the wires, as I could show you that, the wires would lead back to the Raspberry Pi. So, and then you would start the flashing procedure for this. It's relatively simple. I guess to show you the pinout, on this the pinout really doesn't matter, because if you buy the clip, there's going to have on revision 2 the actual pinout on the back end side of it, and you can see, well, you probably can't, but starting from the top down, that's 3.3 volt, and then not applicable, you've got clock, C, ground, not applicable, SO, and CS. So sorry if I got a little bit blurry there, just trying to read it myself. The camera's directly in front of me. And so you would just hook those up to where they would go on the Pi, and you can see that I've got yellow, which is CS in this case, black, which is my MISO, I've got this orange, which is my 3.3 volt that lead back to here. And then I've got the mossy, which is white. I've got the ground, which is green, and I've got the clock, which is an orangish red color. And those would all hook up on the Pi on the different pins, starting over at pin 17. I'll go ahead and put a picture up of where you would hook these, and I'll just have a little diagram that pops up right now. And that diagram should show you exactly how to hook up the clip back to the Pi. I'll also have a written tutorial that are going to have pictures as well for all this, so look for that. That'll also be in the description below. Now that we know what we're doing and basically how to do it, it would be the same thing for this. I believe red is 3.3 volt. The green is clock. The black is ground. The blue is the chip select or CS. The purple is miso, and the mossy is the orange. Anyways, so now that we know what we're basically doing and how to hook it up to the Pi and back up to the board, I'm going to go ahead and get into the flashing procedure, and we'll just go from there. We'll see you guys in the next portion. Hey everyone, we're on the second part of the video where we're going to SSH into the Raspberry Pi that I have set up here. Basically you would hook it up to your network and set up everything for SSH, and you would clip it up to your MacBook Pro or MacBook board or MacBook Air, and you would commence flashing. So I'm going to go briefly through the setup that you're going to need to do, and then after that we're going to go ahead and jump into Flash ROM and the commands that you're going to run. I'm going to go ahead and throw up a couple pictures throughout the tutorial on what you're going to be seeing when you're hooking up the clips, and a couple other things. So just keep looking for that, and pause the video as needed. I'm going to try not to stutter too much in this, but here we go. So I'm on a Windows box, obviously, and I'm using PuTTY to SSH into it. I've got it saved here as Mac Attack, kind of cool. And I've got the Raspberry Pi image, like I said, you can download for the Raspberry Pi Model B. And if you did download the image I have, then this next little bit, 5 minutes, is probably not going to be for you. But to get into it, it would be Pi and then Mac Attack. Once you're in, I'm going to go ahead and full screen this. If you're first setting the Pi up, then you're going to come up to the configuration, or if you've already passed the configuration, you want to make sure you have the settings right. Go ahead and go to sudo raspi-config and expand your file system. Change your user password if you want. You can enable whatever kind of boot that you want. You need to change your international options for your keyboard and your language selections, so you don't have any mess ups, especially with passwords if you made them complicated, or with special characters. You can overclock it. I've got a modest overclock. The advanced options, you want to turn on SSH if you're going to SSH into it, and definitely turn on SPI, and just say yes to everything basically. And then that's about it for the options. It's all you need for this. After you reboot your Pi, because it's going to say that everything's going to take place or be configured after the reboot, you're going to need to go into your Raspberry Pi Blacklist, and you can get that from a link. I'm sorry, not a link. You can get that from here, basically by typing in sudo nano etc modprobe.d raspi-blacklist.conf. If you have nothing in it, you're good to go. If you see something such as Blacklist space SPI -BCM something or another, then you need to go ahead and comment that line out and move on with the tutorial. You would save it by hitting Control X and then hitting Y and then enter. In this case, I haven't made any changes. I just hit Control X. Once you're
your Blacklist file has been updated to comment out the SPI section, you need to do some upgrades. First thing you need to do is an sudo apt-get, oh man, can't type, update. That'll update your repository list and all the repositories for all the applications. Then you're going to do an upgrade that will upgrade everything. This will take a few minutes, and after you get that done, you need to go ahead and install a couple things. And the things you need to install are PCI utils. You would want to install that, run through the setup for it. You would want to do lib ftdi-dev, I believe, and then you would have wanted to do libusb. I said lib ftdi, just to let you know I misspelled it. Then you want to do libusb, and then finally libpci. libpci is probably already installed or at the latest version, so don't sweat it. You shouldn't run into any errors here, and if you do, just kind of try to overcome them or hit my forums and I'll help you out. If you have my image, you probably won't unless you put the image on a Pi 2 or something like that, because the image is for the Raspberry Pi Model B. After you've installed everything, you're going to want to get Flash ROM, and the way that you're going to get Flash ROM is you're going to clone the Git repository. And you can do that by typing in this command, sudo git clone, and this is the link. It's https://github.com/ghcloos, I believe that is, /flashrom.git git. And that's going to clone it into a folder called Flash ROM. I'll run through the motion. It should take a few moments. And once you get that done, you're going to travel into the folder by changing directory into Flash ROM, the folder, and then you're going to make the install. You're going to make it, and then you're going to make install. Just run those two commands, and I'll show you what that looks like. I'm not going to actually run the commands because I've already got Flash ROM installed, as this is the image I'm using. But we're almost done here, so you would first, let's ls to see that we have a Flash ROM folder. The Flash ROM-master is mine. And anyways, so you would change directory into Flash ROM, and then you would do a sudo make, and then a sudo make install, and that would install everything for you. And then you'll be able to, let me change directory out of this real quick. And then I'm going to remove this because I don't need it. And the working directory we're going to use is EFI. It's already on the image that if you have mine. We're going to change directory into it. ls, there shouldn't be anything in there. Once you're here, you can go ahead and start with Flash ROM. Basically, just to get a little help on it, you can type in Flash ROM wants the help command, and it'll show you everything that you really need to know about Flash ROM and a little bit of an example. If you need further instruction, just man Flash ROM. That will bring up the manual for it, and you can scoot through here and see what you can do with it. Alternatively, you can just watch my tutorial and I'll teach you basically how we are going to do this flashing of the EFI. So we're here, we've got the clip hooked up to the board, or the MacBook Air clip that you purchase from me, or you make, or you want to purchase from Lord knows the guy that sells it for $100. And anyways, you've got it hooked up to your MacBook Air Pro, and the wires are hooked up to your Raspberry Pi's GPIO pins, and you want to test the connection. This is what we do. You type in sudo before everything because it needs the super user do rights. Flash ROM, because that's the program that we're calling. We're going to read, so it's a TAC R, and we're going to read it into the tilde, which is your home directory, and that's /EFI because that's the directory I want it to go in, and then we're going to name the file test1.bin for binary. and then I'm going to tack capital V for verbosely. That means give me as much output as possible, that way we can catch some errors. And then tack P for the programmer. In this case it's Linux underscore SPI, and then we're going to do a colon, and then the device is going to equal your dev SPI dev 0.0, because we're going to call the SPI device from the GPIO. So if you looked at the header sheet for the Raspberry Pi, you will be able to see what pins are used for what, and SPI pins are the ones that we're hooking up to. So once I run this, it's going to read the flash into EFI directory within my home directory to test1.bin, and it's going to verbosely do the output. I'm going to go ahead and try to catch some of the output and tell you what it's doing. Obviously it initialized, and if you come down to this section here, if you can see my mouse, it says found SST flash chip, so it tells you the chip version. You can notice it's a SST 25. So if you're undecided about your chip, as long as you can find a 25, if it's a 25 series chip, then it's probably the EFI chip. It says some block protection and EFI disabling, so it disabled the block protection. Right now it's reading the flash. I'm going to talk a little bit while it's reading the flash, and if it gets too long, I'm going to go ahead and pause the video. So now would be a good time for me to quit talking because it already read the flash. I think the flash on this one is just 2 megabytes. Later versions, this is an earlier version board. Later versions are a little bit more. They're about 8 megs, and it takes considerably a little bit longer, about 10 minutes to read the chip. So anyways, once we have the EFI, we're going to go ahead and just ls in our directory to see that test.bin is here, and you can see from the designator that I'm in EFI. So if you're on a Windows box like I am, you can, if you already have installed the PSAP, which I do, you can get that from the PuTTY page as well, and just drop it into your Windows System 32 folder, and run a PSAP command. So PSCP, I'm going to take from the user Pi at the IP address 10.72.117.22, I believe it was. That's the IP address of my Raspberry Pi, colon, so we're going to go to the directory, and it's going to be in, I know I used the tilde before, but it needs to be the full path. So /home /pi because it's the user, EFI because that's the folder that it's in, and then we named it test, I think it was test1, right? Yeah, test1.bin, and man, we didn't give it the destination address. I'm just going to drag a file over here and then backspace on the file name because I'm just going to save it to the desktop. What am I doing wrong? Oh, I didn't put a space. So bear with me. I make mistakes too. It's going to ask you for the password, so type in Mac Attack if you have my image. And it's going to transfer the file over, as you can see. So that's a good way to transfer files from a Linux box or your Pi. And this one right here, I don't think we can modify. So you would actually have to have a clean dump, which you can pull off of my website, by the way, GhostlyHaks.com. I have a repository in the downloads section. But I'm going to open it up into Notepad just the same. And since we have it open in Notepad, we're going to do a Control F to search. You can see I've already done a couple searches on it, and we're going to search for $SVS, and I'm going to count, and I see 0 matches, so that's pretty much a dead end right there. There's a couple other places at the password jump, which is what I call it. It's actually not where the password lives. It's a call to where the password lives, I'm pretty sure. I mean, I could be completely wrong about that too. Token.paul on my website is a phenomenal guy, and he's a leader in one of the projects that we're doing, and he knows a lot about the whole EFI password removal deal. He knows a lot more than I do, actually. His research is really advanced. So anyways, I digress on that. The password's not here, so what you would need to do is you need to find the serial number of your Mac. So let's just type in HWC, and we're going to count that out. There's only one match. We're going to jump down to it, and that doesn't look like this must be a really old version of the firmware. I wasn't really expecting that. Hopefully I got a good read on this. Usually what you would do is you would read it off 3 times and you would compare the reads. You can do that through an MD5 check. But usually you would look for HWC. Let me go ahead and just stop with this dump right here. You understand how to dump, and you can do it multiple times if you needed to. Let's go to the 2559. This is a locked binary for the EMC number 2559 Mac. Yeah. And we're going to do the same search. You can search for the SVS, and this is what you would see on a Mac that you could unlock just by changing the EFI firmware. So we're going to count, and I see 2 matches. I'm going to find next. It'll take me to the first match. If you hit find next twice, or 3 times in this case because there's only 2 matches, you come to the first occurrence of it. What you would need to do is you would need to, you see these values here, the Y's, they look like Y's. You would to get the amount, the same amount of Y's as there are. Basically, you're going to null value this whole section out right here, and that's the end of it here. And you would replace it with these Y's right here. You need to make sure that the file size is absolutely the same file size. That's probably the best advice I can give you. You're going to have problems reading it back if it's not. So what I was getting at is we're going to find HWC. If for some reason you didn't have those money sign SVS in your firmware file, you can go to, let's count SVS, find next. That's not the one we want. This is the one we want. You see how it says SON, then EOF, which is end of file, I believe. You can scoot back, and this is where your serial number is going to be. You can grab that serial number and drop it into a site that I use frequently. I'm going to go ahead and grab a window and throw it up here. Let's just type in Mac lookup. Ta-da-da. And go to Ultimate Mac Lookup. Drop your serial number into here, look it up, and you're going to see the different models that it could apply to. In this case, your serial number for this one is a MacBook Air Core i5, 1.3 gigahertz, 13-inch screen, mid-2013, and it's the EMC 2632. So if you see that EMC number, you can right-click and copy, and you can go to my website, GhostlyHaks.com. My computer's really slow. This Windows box is terrible. The internet is blazing fast here, but anyways, you go to EFI firmware from the cloud here, stands for downloads. And look, Token Paul's online, so you guys could have talked to him. Type in 2632 because it's the EMC number, hit enter, and you can search and see if I've got your firmware. In this case, I know I have the firmware because what I was just reading was the firmware that I modified, and I dropped it onto the site here. So if there's a download button, you can download the firmware and you're good to go. Let's go ahead and start cutting this video short. That way you can request firmware by using your serial number or your EMC number. You can see if I have it on the site. You can see if other members may have it or be able to dump one for you. Or you can modify it. And I'll go ahead and put in the tutorial how to modify the firmware. I guess I could bring it up really quick since we're already here. Let's go ahead and search the SVS. Let's make sure we're at the first occurrence. screen right here. It says first occurrence. And what I would do is I would grab just in front of where the money sign is, and I would drag across. Be careful with it. And once you get here, I would copy that, open up a new page, and I see that the length is 136 and it's at 107 columns. So you can sit here and do the math about it, or you could come back and just do like I normally do. I'm pretty lazy, and I will grab a section of Y's and I will count or copy them, and then I remember 136, and I'll Control A and then backspace, drop it in here, and I have 138 right now. So backspace 1, you're at 136. Control A, Control C to copy that because we're at 136. And I'm going to attempt to drag across. This is pretty much easy because there's something below it. And I'm going to Control V that into there. Now I need to remember where this is, so I'm just going to leave the screen up and I'm going to hit Control S to save it. This is the 2559 locked.bin. And I'm going to check the properties to get the exact file size, and it's 8388570 bytes, and compare that with this one here, which I know is good. And you have 8388608, so we have a few bytes that we need to get to. It looks good on disk, but the actual size is not good. See how these both match up? So we're going to go ahead and we're going to add a few more in there. I think it would be safe to say to just paste it one more time, and then we can just delete some if we need to. So I'm going to save that, and we're going to check the file again, and this is 638 instead of 608, so we need to get rid of 30. Let's come back here, and I'm just going to try to get rid of 30. And I'm going to save again, right click, properties, and here we are at 8388608, which is the exact same size as the other one, and you want it to match up. And you can find out the exact size of your chip, which this needs to match the exact size of your chip. So any modifications that you do, such as knopping some stuff out, you really need to make sure that you get it back to the exact size of the chip. You can find that in the chip's data sheet, which you can find online easy. And if you guys are looking for your data sheet, just ask us on the forum. We can find it for you. Once you do that, I'm going to go ahead and Control Z until I get back to where this was locked again and save it. But once you do that, you can go ahead and take your firmware that you've modified and you can PSAP it back. So you would basically just take this out, and you're pulling the file from your desktop, whatever the file name is going to be. Let's just pretend like it's foobar.bin. That would be a fake file name that I'm giving you guys. To send it back over. So once you do that, you can hop back into your Raspberry Pi and you can attempt to flash the firmware back to it. And I'm just going to go ahead and flash the test1.bin back to it. And it's pretty easy. Just hit up on the keyboard and you're going to get your history. And you're going to leave the Linux SPI all the same. This is your device or your programming device verbosely, and then the test.bin, we're going to flash it back, so I'll leave that the same, but you would need to put the file that you want to write here. And there's only one difference in this command, and it takes the R to a W. The W means write, so whatever file name that you put here, you're going to try, or it's going to try to write to this chip that's connected to the SPI device. So everything's still hooked up the same. I'm going to go ahead and write back, and you're going to see that it's reading the old flash contents. It shouldn't take too long, so we're going to just chill for a second, and you're going to see what it looks like when it's writing. I'm pretty sure this video is getting lengthy, but I'm guessing you guys are probably going to appreciate it being lengthy and having ample amount of detail in it. And if you guys have any questions, post them in the comments below, or better yet, open a case on my site. Basically, go to the site, the forums, and start a thread, and I'll help you out the best that I know how. And I'm sure Token will help you out as well. We've actually flashed chips for people. So it says, warning, chip content is identical to the requested image. Erase, write, done. I think what it means by the requested image is the actual image on the chip itself, so it doesn't actually have to modify any registries. This is, by the way, most of the time when you're flashing, you're not going to see it. It's going to flash for quite a minute. So I'm going to go ahead and show you what it looks like when I'm reading. This is just going to be very brief. I'm just going to hook up the Pi to the MacBook Air board. You know what? I'm not going to worry about going through all that. You guys know what it looks like. It's going to look like this, but it's going to take a lot more time, and it's going to continue to scroll through stuff. All the registries that it's going through. Like I said, this is a 2 megabyte chip opposed to an 8 megabyte chip. For some reason, this reads really fast, and on the MacBook Airs, it takes about 10 minutes to read and about 10 minutes to write. And if you leave the write command the way it is, it's going to, the way I have it posted here, it's going to read the chip, it's going to write the chip, and it's going to verify the chip. You can obviously use any mixture of those commands if you learn Flash ROM better. I guess I'll go ahead and I'll cut it short from here. I appreciate you guys watching. Like I said, if you have any questions, concerns, comments, if you want to buy the MacBook Air clip, which would be used to interface with your MacBook Air's EFI and not have to scratch back traces and solder to the motherboard and remove the motherboard to solder to it and blah blah blah, because the chip is a ball grid array on the bottom side, then you can contact me at admin@GhostlyHaks.com, or you can contact me on the site. I'm there virtually every day. Anyways, good luck everyone, and we'll see you next time on the next tutorial.